Hello, fourth graders. This is Miss K, and we are on lesson 5 of our Unit 5 Ecology. So your vocab, this is actually the same chapter as last lesson, so we'll review the vocab one more time, and then we're going to look closely at a couple sections from that chapter. So an eyewitness is a noun, and that's a person who has seen something happen and is able to describe it. An experiment is a noun, a scientific test to try out something in order to learn about it. A fault is a noun, a crack in Earth's crust. Heave is a verb, to move up and down over and over, or to lift, pull, push, or throw with a lot of effort. Trigger is a verb, to cause something to start or happen. Pinpoint is a verb, to figure out the exact location of something. Magnitude is a noun, and that is an earthquake's strength. Aftershock are smaller, weaker earthquakes that follow the main earthquake, and that's a noun. A tsunami is a noun, a gigantic wave of seawater caused by an earthquake in the oceanic crust. And then surge is a verb, which means to move forward quickly, suddenly, and with force. All right, number 1 is a quick review. Which one of those text features will tell us the definitions to a word? So is that called the table of contents, the glossary, the headings, or the graphs? I know many of you don't have your actual book with you, but think about text features that we've learned about for the past couple years. Which one tells us definitions, meanings of words? All right. So the first question we're going to look at is, what words does Francesco Petrarch use to signal he's describing an earthquake? So we read this last lesson. This is the passage where Francesco was writing about an earthquake experience in the Middle Ages. So you're going to pull out the words that tell you how he's describing it. The floor trembled under my feet. When the books crashed into each other and fell down, I was frightened and hurried to leave the room. Outside, I saw the servants and many other people running anxiously to and fro. All their faces were pale. So what one of those words, or which words, tell you that he is describing an earthquake? All right, the next one, we're looking at most earthquakes happen at blank boundaries. Let's see. As you read in Chapter 2, scientists developed the theory of plate tectonics in the 1960s. The theory explains how Earth's surface and interior changed over long periods of time. Some plates are pulling apart at their boundaries, other plates are colliding, and still others are sliding past each other. A lot happens at plate boundaries, including most earthquakes. In fact, one of the easiest ways to locate plate boundaries is to determine where earthquakes are occurring. And this map shows us the locations of those plate boundaries and centers of previous earthquakes. So which one of those is where those earthquakes are happening? How does this experiment help you understand what happens at a fault? It says, try a little experiment. Extend your arms out in front of you and put your hands together. Keep your palms and fingers flat against each other like this, and press your hands together. Gradually increase the pressure. When you can't press any harder, let your right hand slide forward, and that sudden slipping is what happens at a fault. So in your own words here, how does that experiment help us understand what's happening at a fault? All right, the next question, we're going to read about the San Andreas Fault. In the United States, one of the most famous faults is the San Andreas Fault in California. It lies along the boundary between two tectonic plates that are slowly moving past each other. The movement, however, is far from steady. For years at a time, blocks of rock bordering the San Andreas Fault would stay stuck. Pressure slowly builds, and then wham, they slip and trigger an earthquake. The 1906 San Francisco earthquake was one of the worst in American history. The sudden slip that triggered it was huge. It caused rocks on either side of the fault to move more than 20 feet in just seconds. So what is released when blocks of rock slip past each other? All right, the next one, it wants to know 2 effects of surface waves. So it says, all earthquakes begin with huge blocks of rock moving along faults. The place in Earth's crust where this happens is an earthquake's focus. Think of it as its earthquake's heart. The source of seismic waves, the focus may be deep in the crust or close to the surface. The epicenter is the point on Earth's surface directly above an earthquake's focus. Some kinds of seismic waves produced by earthquakes travel deep into Earth's interior. Surface waves, however, are seismic waves that are first noticeable at the epicenter. During an earthquake, surface waves are what make the ground shake, heave, sway, and lurch. They are the cause of most earthquake damage. So 2 different effects of surface waves. What happens because of these surface waves? All right, your next questions are about the tsunami passage. Number 7 asks, tsunamis are a blank result of an earthquake. So are tsunamis something negative or something positive? And then you're going to give evidence from the text that supports your answer. So if you think it is negative, find something here that tells you that it's negative. And if it's positive, you're going to find something here that tells you that they're positive. All right, so that's it for reading. Let's head on over to skills. So your first 2 questions are talking about the seismograph and the Richter scale. So you're going to tell me how are they different and how are they the same. So here is the Richter scale. It says the Richter scale is another way scientists measure an earthquake's magnitude. The Richter scale assigns a number to an earthquake based on the largest seismic wave recorded for that earthquake. The higher the Richter scale number, the stronger the earthquake. So the Richter scale is a scale. It gives the earthquake a number, and that number tells us how strong or how weak that earthquake was. Now, the other one was the seismograph, and that talks about it right here. So scientists use seismographs to measure an earthquake's strength or magnitude. During a small earthquake, Earth's surface may shake only a little. The seismograph shows these relatively low energy seismic waves as little wiggles. During a big earthquake, Earth's surface shakes a lot harder, and the seismograph shows these high energy waves as big zigzags. So one way that those are different and one way that those are the same. All right, so this is the same passage that we just talked about, the tsunami passage. So I'm going to read it and you're going to take some notes based on this small section here. So we want to know, what is a tsunami? What causes a tsunami? How fast does it travel? Can we stop them from happening? And how can we prepare and protect ourselves from tsunamis? Earthquakes at sea. Remember that most earthquakes occur along the boundaries of tectonic plates. Several plate boundaries are in the ocean, so many earthquakes occur in the oceanic crust that forms the seafloor. This is especially true around the Pacific Ocean. The Pacific has many deep ocean trenches along the edges of its ocean basin. Ocean trenches form where one tectonic plate is sliding or subducting beneath another plate. Earthquakes are very common in the continental crust along ocean trenches. Earthquakes that occur in the crust, forming the ocean bottom, can cause the seafloor to shift. This shift can cause seawater from the ocean bottom to its surface to suddenly start to move. The result is a gigantic wave called a tsunami. Tsunamis travel fast, as much as 500 miles per hour. Out in the deep water in the middle of the ocean, you'd hardly notice this great pulse of water passing by. All that water piles up as the tsunami approaches a coastline. It becomes a towering wall of water that may be as tall as a 3- or 4-story building. The tsunami crashes onto the shore with incredible force, and it surges far inland. Then it goes roaring and churning back out to sea. Tsunamis can cause terrible destruction. And also make sure you're using the information up here as well. about earthquakes in general. All right, so your last couple questions today, I'm going to have you fill in the blank here. So a volcanic blink is sudden and violent. Which word makes sense? Sometimes my dog blink my sleep when she barks in the middle of the night. And the last two is going to be a little introduction to quotation marks. So there are 3 different ways that we use quotation marks. Anytime someone is speaking or there's dialogue happening in a text, you're going to see those quotation marks on the outside of the dialogue. So if it's in the beginning, so if what they're saying is in the beginning, you're going to put the quotation marks around whatever is being said. You're going to end it with a comma. And then he said is separate because he's not saying he said. The only thing that goes in those quotation marks is what is being spoken. Same thing if it happens at the end, it's just the opposite. So there's a comma after he said, the car is red, period, and quotation marks. Sometimes it's on both sides. So the car, comma, that's what he's speaking. The car, he said, is red. All right, so this is the first time you're doing this, so it's probably not going to be perfect, but try your best anyway and use this little chart here to help you, okay? So you're going to rewrite these 2 sentences, and you're going to insert any commas and quotation marks wherever they belong. And that is all for this lesson. Have a wonderful day. I will see you all next time. Bye, Adams.